In this video, we're going beyond a high-level explanation. We'll walk through IPsec negotiation packet by packet, exactly as you would see it in a capture, covering IKEv1 main mode and quick mode. This is the level of detail you need when reading IKE logs or troubleshooting site-to-site VPNs. The negotiation begins with the initiator sending the first packet. All IKEv1 negotiations start on UDP port 500, the standard for the ISAC camp framework. This first packet's ISAC camp header contains the initiator cookie, while the responder cookie is set to 0. The exchange type is main mode. These cookies are random values that uniquely identify the exchange and protect against denial of service attacks. The payload sequence starts with the SA payload. Inside this, the domain of interpretation indicates IPsec. One or more proposal payloads are included, each defining the protocol ID and number of transforms. Each transform specifies the encryption algorithm, hash algorithm, Diffie-Hellman group, authentication method, and say lifetimes in both seconds and kilobytes. The responder replies with message 2, selecting one matching proposal and transform set. Now, both peers prepare for key generation. Each side sends a key exchange payload containing their Diffie-Hellman public value, and a nonce payload, which is a large random number. These values derive the shared secret and future keying material. At this stage, the communication is still not encrypted. Using the shared secret, nonces, cookies, and authentication method, both peers derive their internal keys. They calculate SKEYID_D for derivation, SKEYID_A for authentication, and SKEYID_E for encryption. From this point forward, IKE messages are secured using SKEYID_E. Now, identity payloads are exchanged, including the IP address or host name. If a NAT device is detected during this phase, the negotiation immediately migrates to UDP port 4500 to allow for NAT traversal. Along with identities, each peer sends a hash payload calculated over the shared secret, cookies, parameters, and identities. The receiving peer recalculates the hash. If the values match, authentication succeeds. At this point, an ISAC camp security association is established, and the secure channel is ready. Now, quick mode begins inside that encrypted channel. The initiator sends a hash, an SA payload for IPsec proposals, and a nonce. This includes an optional key exchange for PFS and ID payloads for traffic selectors. The SA payload now defines ESP or AH, the encryption and integrity algorithms, and the mode, either tunnel or transport. A new SPI is included to identify the outbound IPsec SA. The responder replies with the selected proposal, its own SPI, and a nonce. It then validates the traffic selectors against its security policy. Using SKEYID_D nonces and any optional DH exchange, both peers derive the final data, encryption, and integrity keys. Separate keys are created for the inbound and outbound SAs. The initiator sends a final hash payload to confirm liveness and prevent replay attacks. At this point, quick mode completes. When you look at an IKE capture, every packet follows this exact sequence. Understanding these flows is key to troubleshooting IPsec negotiations effectively. So the next time an IPsec tunnel comes up, remember, it's not just a connection being established. It's a precise exchange of identity, cryptography, and trust happening behind the scenes. And all of it is visible, packet by packet, if you know where to look. If you want more deep dives like this, consider subscribing.